Good morning, all. In today's class, we'll discuss module number 1, that is basics of mechanisms. So, basically, uh, these subjects, theory of motion deals with the relative movement between the components. Okay, so we have different machines. All the machines are made up of different mechanisms. Okay? Basically, mechanisms are used to transfer the relative motions from one component to other component, and we are receiving some kind of energy and we are doing some useful work with the help of these machines. Okay, so this subject deals with all the relative motions between the various components and forces which is involving during the motion transmission. Okay, so just I would like to brief about the kinetics, kinematics, dynamics, statics, what is mechanics, and how that classifications is evolved. So basically, if you go with the engineering mechanics, so we are evaluating the different forces, different motion transmissions. So first is we have the mechanics where we are involving the rigid components or rigid bodies for the motion transmission. Second, we have deformable bodies, and third is we can transfer the motion with the help of fluids. So these are the basic classification of engineering mechanics, which involves mechanics of rigid body, mechanics of deformable body, and mechanics of fluid. Now again, rigid bodies, mechanics of rigid bodies classified into two types, statics and dynamics. So statics means when the forces are acting on a component and the body is at rest position. Dynamics means it deals with the forces while body is in motion. Okay. Again, that dynamics is classified into two parts. One is kinetics, second is kinematics. So kinetics is nothing but whenever we are talking about forces into account for motion transmission, then it will be a kinetics. Kinematics means we are not involving any forces that are responsible for motion transmission. So that come under the kinetics. So this is the basic classifications which we have seen. Okay. Now, in our case, like in the theory of machines, what we have different machines and mechanisms. I'm going to identify how many links are available, which link is fixed, which link is rotating, how that motion transmission is occurring from one component to other component, how that contact is going to occur, whether it is a line contact, point contact, and how many degree of freedom is required to achieve that motion transmission. So this all part we're going to study into these subjects. Okay. So just look at the part. So what we have this kinematic motion transmission for reciprocating steam engine. So it consists of different linkages. Okay. So whenever we are saying a link is nothing but a single part or single component, we can say, which is connected to some other part, okay, for motion transmission. So if you look at the Saturn mechanism, so what we have in this case, we have crankshaft, we have connecting rod and piston. So motion transmissions will going to occur from that crank to connecting rod to piston, and pistons will try inside that cylinder. Okay, so this is all about how that movement will going to happen and how many linkages are connected, how that degree of freedom is how many degree of freedom is required, and how we can achieve the motion from rotor direction to linear direction that we need to study. So if you look at this assembly of reciprocating steam engine, how many linkages we have? We have crankshaft, that is our first link. Second, we have crank. We have third link as a connecting rod, and we have fourth link as a piston, or you can say slider, just sliding inside that particular cylinder. So number of linkages which are used for this motion transmissions are four. Okay. Now, first we need to understand what kind of linkages we can use to design the simple mechanism. Now, in this case, what is happening? All these linkages are rigid linkages. That means that link will not get deformed during motion transmission. So, if link is not deforming during motion transmission, then that link is known as a rigid link. Okay. So, just we'll discuss how we can find out the how we can decide the link and how we can use the different link for achieving the movement or motion transmission. Okay. So we have these three types of links. Okay. Rigid link, flexible link, or fluid link. Okay. Now, in case of the rigid link, which rigid link means it is the link which will not going to deform while transmitting the motion. Okay. Now, these are the links, like suppose a connecting rod, crank, okay, again, you can say piston pin, gudgeon pin. These are the parts, okay, or again slider, you can say, that are not going to deform during motion transmission. So, if you look at the arrangement, so when we are transferring motion from this crank to piston, okay, motion will get transferred from crank to connecting rod to piston. So input motion is our rotary motion. Output motions we are getting a linear motion. But during all this motion transmission, not even single link is going to bend or it will get deformed. So that's why these links are known as a rigid link. Okay. So basically, rigid link will not going to deform during motion transmission. Then we have second part of flexible link. So flexible link is nothing but it is the link which will partially deform. Okay, that will not affect the transmission of motion. Like suppose the example of belt drive, chain drive, rope drive. Okay, so whenever this belt drive is subjected to some tensile tension and tight side and slack side, so at that time it may happen that there is a deformation in micron, but it will not affect the motion transmission. Then third part we have fluid link. So basically, a fluid link is the link which is uh, transferring the motion with the help of fluid. Either you can use a pneumatic fluid or hydraulic fluid. So with the help of this pneumatic fluid pressure and hydraulic fluid pressure, you can achieve the motion between the two components. Like if you take example of hydraulic press, jacks, pegs. So again, this is the example of fluid link where we are suddenly closing that particular part. So maybe mechanical, chemical, mechanical. Okay. Now, what we have basic difference between machines and mechanism. Machine is a rigid member, which will not going to, machine consists of different mechanisms. Structure is a rigid member. So in structure, we cannot, with the help of structure, we cannot transfer the motion. It is just used to hold the particular component, or you can say particular load. Okay. This is all about the systems which we are using. So basically, in case of machine, various mechanisms are connected to each other. Okay. In case of structure, only members are connected to each other. Okay. So this is all about how we can achieve motion transmission in that system.